Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the deduction of molecular formula, or we can say formula unit of an ionic compound. So in the previous lectures of ionic compound, we have talked about the example that sodium chloride. Let me take today some different examples. Let's start with the magnesium chloride. It's magnesium chloride. For magnesium chloride, we have to deduce the formula unit. So for that thing, let me write the first of all element magnesium. So now what's the atomic number of magnesium? It's 12. What will be the configuration? It will be 2, 8, 2. Here what's gonna happen? Magnesium will lose these two valence electrons to acquire stable noble gas configuration of nearest inert gas neon. So what's gonna happen? That magnesium will lose its 2 electrons from the outermost shell, that is valence electron, to acquire magnesium 2 positive charge. So the magnesium will lose its 2 valence electron to acquire stable noble gas configuration of nearest inert gas neon, and will have the oxidation state of 2 positive, or we can say the charge of 2 positive on magnesium. Now let's talk about the another element, that's chlorine. Let me write the I'm writing chlorine over here. Now what's the atomic number of chlorine? It's 17. What's the configuration of chlorine? It's 2, 8, 7. Then what's gonna happen? Chlorine will try to gain one more electron to acquire stable noble gas configuration of nearest inert gas, that is argon. So that means what's gonna happen? Chlorine will acquire only one electron. According to the configuration, chlorine will gain, or chlorine will acquire or gain one electron to achieve stable noble gas configuration of nearest inert gas, that is argon. So due to which chlorine will acquire 1 unit of negative charge. Right? Now magnesium is losing 2 electrons, whereas chlorine is gaining only 1 electron. So at this point what we have to do? We will have to take 2 chlorine atoms then. So I'm writing another chlorine over here. Its atomic number is 17. The configuration will be 2, 8, 7. It will gain 1 electron. This chlorine also will gain 1 electron to acquire 1 unit negative charge. That means the 2 electrons that has been lost by the magnesium will be gained by 2 chlorine atoms. That is, the electron that has been lost by magnesium will be gained by this chlorine atom, and the another electron which has been lost by the magnesium will be gained by another chlorine atom. So that means what we got? We got 1 magnesium 2 positive cation and 2 Cl 1 negative anions. So that means the formula unit comes out to be MgCl2 for the magnesium chloride. I hope you got the point. If magnesium has lost 2 electron but chlorine is gaining only 1 electron, so that means we have to take 2 chlorine atoms to gain that 2 electrons that has been lost by magnesium. So it comes out to be MgCl2. Let me take another example. Let's talk about the aluminium chloride now. I'm writing aluminium chloride. Now I'm writing first of all aluminium. Now what's the atomic number of aluminium? It's 13. So configuration comes out to be 2, 8, 3. Here what's gonna happen? aluminium will lose its 3 electrons from the valence shell to acquire stable noble gas configuration of nearest inert gas neon. So what's gonna happen? That aluminium will lose 3 electrons. The first electron, the second electron, and the third electron. And then aluminium will acquire the charge of 3 positive. Now let's talk about the chlorine now. I'm taking chlorine over here. What's the atomic number of chlorine? It's 17. The configuration comes out to be 2, 8, 7. So here chlorine will gain only 1 electron to acquire stable noble gas configuration of nearest inert gas, that is argon. So that means chlorine has gained 1 electron to acquire stable noble gas configuration of argon, and it comes out to be chloride ion with a charge of only -1. So here we can see that easily that aluminium has lost 3 electrons, whereas chlorine has gained only 1 electrons. So what's gonna happen? We have to take now 3 chlorine atoms to gain all the 3 electrons that has been lost by aluminium. So that means we have to take 3 chlorine atoms. That means I'm writing our chlorine over here. It comes out to be 17. It's 2, 8, 7. So this chlorine will also gain 1 electron and will acquire a stable noble gas configuration of argon, and it becomes Cl1 negative anion. And I'm gonna taking one more chlorine because we have to gain 3 electrons that has been lost by aluminium, and chlorine gains only 1 electrons. That's why we have taken 3 chlorine atoms. So here also chlorine will gain 1 electron to form Cl1 negative anion. So what's happening over here? The first electron lost by aluminium has been gained by this chlorine. The second electron that has been lost by aluminium has been gained by this chlorine, and the third electron that has been lost by aluminium has been gained by this chlorine. So what we got? Here we got 1 aluminium, 3 positive ion, and we got 3 chlorine, 1 negative ion. So that means our molecular formula comes out to be AlCl3. The formula unit or molecular formula for ionic compound aluminum chloride comes out to be AlCl3. So it is the simplest way by which I am showing you how to deduce the molecular formula for any ionic compound. So now let's come to the next trick. For that, let me write down some elements of group number 1, 2, 13 and 16, 17, 15, 16 and 17, sorry. So let's talk about the group number 1 first. The group number 1 is lithium, sodium, potassium, rubidium, cesium and francium. The group number 2 is beryllium, magnesium, calcium, strontium, barium and the radium. The group number 13 is boron, aluminium, gallium, indium, thallium. On the other hand, the group number 15 is nitrogen, phosphorus, arsenic, antimony, bismuth. The group number 16 is oxygen, sulfur, selenium, tellurium, polonium, and finally the group number 17 is fluorine, chlorine, bromine, iodine and astatine. So now why I have written the elements of group number 1, 2, 13 and then 15, 16 and 17? Because most of the ionic compounds are formed within these groups. The first set of 3 groups usually form cations, and the another set of three groups, that 15, 16 and 17, forms anions. So now let me write their oxidation states group wise. The group number 1, shows the oxidation state of plus 1. That means Li positive, Na positive, K positive, Rb positive, Cs positive, Fr positive. According to their electronic configuration, the group number 1 will show the oxidation state of plus 1. Now let's talk about the group number 2. The group number 2 will show the oxidation state of plus 2. That's plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. The group number 13 will show the oxidation state of plus 3. That's plus 3, again Al plus 3, gallium plus 3, iron plus 3, Tl plus 1. It's inert pair effect, which we will discuss in the next lectures. Now let's talk about the group number 15. The group number 15 will show the negative oxidation state of minus 3. That's minus 3, minus 3, minus 3, minus 3, and the bismuth is actually metal. It will show the oxidation state in positive. Now let's talk about the group number 16. The group number 16 will show the oxidation state of minus 2. That's minus 2, minus 2, minus 2, minus 2, and then minus 2. Group number 17 will show the oxidation state of minus 1. That's F negative, Cl negative, Br negative, I negative, and St negative. So now what's the next trick to find the formula unit or the molecular formula of the ionic compound? Let me talk about again magnesium chloride. I'm talking about again magnesium chloride. What we have to do, just write magnesium and write chlorine over here. Now magnesium belongs to the group number 2, so the magnesium will have an oxidation state of plus 2. Now chlorine belongs to the group number 17, so it will have an oxidation state of minus 1. Now just ignore the signs. I'm ignoring the signs. I'm taking the magnitude. Magnesium is 2, Cl is 1. Then what we have to do? We have to cross multiply it. Magnesium with 1 and chlorine with 2. So that means we got our molecular formula to be MgCl2. I hope you got the point. Firstly write the oxidation states, then ignore the signs, that become valences, and then we have to cross multiply it. Let me take another example. Let's talk about sodium oxide. Now I'm talking about the sodium oxide. Sodium oxide. What's the symbol for sodium? It's Na. What's the symbol for oxygen? It's O. Now the oxidation state of sodium is plus 1. Just write plus 1 over here. And what's the oxidation state of oxygen? It's minus 2. So I'm writing minus 2 over here. Now just ignore the signs and take the magnitude. It has become valences. Now cross multiply it. Oxygen with 1 and sodium with 2. So it comes out to be Na2 and the oxygen 1. So we got the formula unit for the sodium oxide to be Na2O. Most of the ionic compounds are always found between the cations of group number 1, 2 and 13 and the anions of group number 15, 16 and this 17. Now let's take another example. Let's talk about the calcium sulfide. Now I'm talking about calcium sulfide. Calcium sulfide. What's the symbol for calcium? It's Ca. What's the symbol for sulfur? Is S. Now what's the oxidation state of the calcium? It's plus 2. So I'm writing plus 2 over here. What's the oxidation state of sulfur? It's -2. So we are writing -2 over here. Now, what we have to do, we have to just firstly ignore the signs. Now we have to cross multiply it. Calcium with 2 and sulfur with also 2. So what next gonna happen? So it comes out to be Ca2 and the S2. Then the simplest whole number ratio for calcium sulfide comes out to be Ca1 and the S1. So it comes out to be CaS. That's the molecular formula or formula unit for the calcium sulfide. Let's take some another example now. Now let's talk about the magnesium nitride. Now I'm taking the last example. Let me take it's magnesium nitride. So what's the symbol for magnesium? It's Mg. What's the symbol for nitrogen? Is N. Now what's the oxidation state of magnesium? Is +2. So I'm writing +2 over here. What's the oxidation state for nitrogen? It's -3. So we are writing -3 over here. Now just ignore the signs. Now we got the valences. Now we have to cross multiply it. Magnesium with 3 and nitrogen with 2. So it comes out to be Mg3 and 2. So it's the simplest whole number ratio, 3 and 2. We got the molecular formula or formula unit for the magnesium nitride to be Mg3 and 2. So that's all for today. I hope you got both the tricks of finding the molecular formula or formula unit for an ionic compound. That's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.